So Project Volterra, which is Microsoft's developer platform for Windows on ARM, is in the hands of developers and content creators, and has been for a little while now, which means just like the last time I talked about Project Volterra, which you can check out right over there, I'm showing up late to the party. But now that I've seen videos of people developing on it, talking about how it performs, giving you solid performance numbers, as well as taking it apart and showing us what's inside, I have a few more thoughts. So let's talk about them. The last time I talked about Project Volterra, I was cautiously optimistic for a couple reasons. The biggest one for me was that the last time I used anything with Windows on ARM, Microsoft's translation layer was terrible. It could only do 32-bit translations, meaning that you had to use either a very slow or a very outdated version of whatever app you were trying to translate. However, that's one of the first positives that I saw when looking at some of these videos, and actually something that has been around for a little longer than Project Volterra. You can now actually have translated 64-bit apps running natively or translated in ARM, getting somewhere between 70 to 80% of the efficiency of the chip and the application if it was made natively for ARM. That is a huge plus for their translation layer, and that means that apps running on this system will perform pretty close to what you would expect if they were made natively for the chip. This is really close to the 70 to 90% efficiency that you would get from Rosetta 2, which is what Apple used for their Apple Silicon platform. And if I'm comparing this to Apple Silicon a lot, it's not that I'm going to be comparing it to Apple's newest stuff like the M2 or the M1 Max or Ultra. I'm mostly going to be comparing it to its closest counterpart, both in price and in efficiency, which is going to be the M1, Apple's worst and oldest chip that's still being sold in things like the Mac Mini. But either way, one of my biggest concerns was out of the way. You have a very efficient translation layer that can run a lot of apps. However, some of the translations aren't quite where they need to be yet, not meaning that they're not efficient, just meaning that they don't quite work. There's a couple videos out there talking about some of the apps not working. Quinn from Snazzy Labs did a great example of some of the applications you'd expect to run, like Dolphin Emulator, that just don't. But having a video game emulator not run well on a developer kit is not a huge deal, because the key goal with this is that you buy it and you get to keep it, unlike Apple's developer kit. And when you get it, you take the applications that are installed on it, which are translated to run natively on ARM. That includes Visual Studio, Office 360, a lot of Microsoft programs, and you run those to make other apps that are either being translated or developed from the ground up to run on ARM. That's really cool, and I'm super happy to see that those apps are still fully translated. I mean, they said that they were going to be when I initially talked about it, and they still are, so that's a plus. And generally, this is just a tiny little box made specifically for developers. It's not focused on the general consumer, but you can buy one if you want, which is kind of neat. And the pricing of $5.99 isn't the worst thing in the world that I've seen. So I guess theoretically, if you wanted to get a developer kit as a competitor for the M1 Mac Mini, you could do that, and you would get the benefits I just mentioned, like natively supported apps from Microsoft like Visual C, the Office suite, and a couple other things, as well as the promise that you're going to get some other native apps down the road, and also a fully capable 64-bit translation layer with 70 to 80% efficiency. But as I began to watch more videos about this, watch teardowns, and actually got to see what was inside this developer kit, I kind of felt like the kid at Christmas who got super excited for a giant box that had been under the tree for a long time, and once you open it up, you realize there's another box, and each box starts getting smaller and smaller until the 16th box wrapped within all these other boxes was just a tiny little package that contained socks. See, my concerns didn't just stem to the software level stuff, my concerns also stemmed to the developer support. And one of the things that you really have to do if you want developers to hop on board is provide something that is worth their time. And I gotta be honest, the Qualcomm 8CX Gen 3 that they use to power this thing, it's okay at best, and it's something I would expect out of like an Android tablet, but those really don't exist aside from Microsoft, and I guess Google's trying to bring them back, but it's not a really great processor, and for the price, it's not a bad price to get that chip, especially considering that if you wanted to get it inside of the Microsoft Surface, you're talking somewhere in the neighborhood of about $1,200 versus this $600, but it's still not a great processor. And like I mentioned, the translation layer to run apps off this chip, if they're not already made for ARM, give you a 70 to 80% efficiency. But when the performance is dwarfed by Apple's oldest Apple Silicon processor, it doesn't really look that great. On top of that, Quinn from Snazzy Labs did both a teardown and a wattage check on these just to see how the board and the processor were performing. And number one, the teardown showed that it was basically a Surface Pro X board or a Surface Pro 9 board slapped inside of one of these little boxes, which is fine. Like, I'm not really going to ask a full-blown developer kit to have a custom board or anything. In fact, when you look at the developer kit that Luke Miani tore down for Apple Silicon, it was essentially a Mac Mini board with an A12Z kind of just soldered in place. So I'm not expecting this mind-blowing difference between the developer kit board and what it was derived from. But it is kind of disheartening that they really just sort of slapped 32 gigs onto a Surface Pro 9 or a Surface Pro X board, and also awkwardly just hung some USB-Cs out the side because, well, they're on the board, you might as well use them. But yeah, it's whatever on that front. But moving away from the board just to the chip itself, the wattage being drawn by this developer kit, it's not great. It's more than what Apple's M1 Mac Mini draws, and also theoretically more than what Apple's M1 platform drew from the laptops as well, which is not just a problem for the desktop. I mean, it's not as big of a problem because it's always hooked to power, but it's a bigger problem considering these chips are already making their way into full-blown 2-in-1s like the Surface Pro 9. So when you throw this chip into a portable device that's being run on a battery, the battery life's not going to be as good as the competition, and in general it's just going to draw more power out of a desktop system as well, which, depending on the power limits, could also mean more heat, meaning that, yeah, it's in a small package, but if you really wanted to ramp up the performance, which is more on Qualcomm's side, what's going to happen when it comes to thermals? My original concerns with this developer kit were hardware, software, and developer acceptance. And when it comes to hardware, it's a dev kit. I'm not expecting the world of it. However, the power draw is not that great. And on top of that, the actual performance coming out of this chip, considering it is an older generation chip, just kind of buffed up a little for this dev kit, it doesn't look great. And funnily enough, when it comes to price to performance, you're probably actually better off, if you're looking to develop for Windows on ARM, you're probably better off buying an M1 Mac Mini, even on the used market, but if you buy one new, it's only a little bit more expensive than this developer kit, and then also a little more expensive to put Windows on it, and you'll still get a better performance. In fact, running a virtualized version of Windows still nets you better performance than what this chip gives you, and it's only a little bit more expensive. And again, if you buy used, it's probably as expensive or cheaper to do. When it comes to my software concerns, those have pretty much been alleviated because the translation layer does 64-bit, does it fairly well, does it very efficiently, which is awesome. And in general, aside from a few bugs that need to be worked out, I think having the 64-bit translation layer as close to Rosetta 2 as it is a huge benefit. And on top of that, having Microsoft's own apps fully translated over already to run on ARM is a huge plus. So assuming that developers, which is my third concern, start hopping on board with this, I think that they do have a good software platform to hop into. Granted, I guess if I were to add one thing, I do wish that Microsoft's translation layer was a little more granular and a little more integrated into the system. One of the things I saw Snazzy Labs bring up was the fact that if you're running a virtual machine in macOS and you're running a virtualized instance of Linux, you can actually use x86 translated layers from Rosetta 2 in Linux through the virtual machine. It essentially means that you can use Rosetta's translation that is already in use for things like non-native apps on Mac, and it still works in a virtual machine. That's really cool. If Microsoft can get to that level of granularity, I think they would basically have a perfect software setup. But lastly is the developer acceptance. And again, hardware I'm not super concerned about. It's packaged nicely enough that it's not really a problem, and these developers have a fantastic software suite to hop into. However, at the moment, Apple's the only one really making a solid chipset, both with the M1 and their variants and the M2 and theoretically their upcoming variants. So with Apple really showing no signs of slowing down, I feel like developers are more inclined to hop on with Apple Silicon because of the fact that that's where Apple is, and there's not going to be an x86 Mac anytime in the near future because of their transition to ARM. Whereas with Windows, you've got a lot of options, and in a lot of cases, developing for an existing platform, x86, 64X, those are all extremely approachable, extremely common, and widely accepted, so probably cheaper. At the end of the day, I'm still kind of sitting where I sat originally, which is that I think that this is a great platform that developers really are going to either make or break. I really hope they make it, just because I'd love to see more competition in the ARM space, because when there's competition between companies, the consumer wins. But overall, I'm still cautiously optimistic. I don't know. What do you all think? Let me know in the comments. Hopefully you enjoyed this video. Make sure to like and subscribe if you do enjoy this kind of content. Like it if you enjoyed, subscribe if you loved it, all that fun stuff. Again, comments down below. I'm curious to know what you all think. Do you even care? I was kind of curious about Project Volterra, and now it has my full and undivided attention, so I might make another video down the road. Either way, that's been it. Thanks for watching, and I'll see you all in the next video. Make sure to be there, and have a good one.